As we move to a sustainable future, the number of electric vehicles on our road are expected to increase dramatically. When these vehicles reach the end of their lives, there's an important challenge. How do we recycle the batteries in these vehicles, both to ensure that the waste is dealt with correctly and also to recover the critical materials that are in the battery? If you've been following some of the other experiments in this series, you'll have learned about the structure of lithium-ion batteries, and you'll realise that in fact they're quite complicated, with a mixture of different materials, much more so than the lead-acid batteries that we find in a conventional car at the moment. These batteries are easy to recycle. We just split them apart and we can separate the lead, which is very heavy, from the plastics, which are light and float. However, with electric vehicles, we've got some challenges. First of all, the batteries are lots of different shapes and sizes. The way that they go together is different. If you look at the packs from a Tesla, a BMW and a Nissan, you'll find that they all use different types of batteries. Teslas use cylindrical cells, which are similar to the batteries that we might find in our remote control, only a little bit bigger. BMWs use prismatic cells, which are hard, plastic and square. And Nissan use a pouch cell, which is a laminated construction of different materials bonded together. Firstly, there's the challenge of removing the battery from the vehicle. Batteries are quite heavy, and so there's a need to remove them safely. High voltages are also present, so there's a risk of electrocution. Once the pack has been removed from the vehicle, we then need to work out how to disassemble it into modules and then into cells. Once the battery's been disassembled and we've sorted out which modules are good and can be reused and which ones aren't so good and need to be recycled, there are a variety of different routes for recycling. Most of these involve shredding at the beginning of the process, and from that shredding we then need to separate the materials. In this experiment we're going to look at exactly that. How can we separate shredded lithium-ion batteries?
Hello there, I'm Dr. Gavin Harper from the Birmingham Centre for Strategic Elements and Critical Materials, and in this exercise we're going to talk about lithium-ion battery recycling. Now, if you followed some of the other exercises in this activity, you're going to be familiar with the structure of lithium-ion batteries and also have encountered some technologies for separation of materials in recycling. We're going to bring those two bits of knowledge together now. So I want you to start with a fairly tall container. This one's just been cut down from a pop bottle. And one of the first things that happens when lithium-ion batteries are recycled is that materials are shredded and mixed together. So you should have some polystyrene balls. These are going to represent the plastics in lithium-ion batteries. So that could be plastic casings, or it could be the separator materials inside the batteries. We're going to put some of these into our container. Then we've got some foils. These represent the electrode foils in the lithium-ion battery. So we have copper and aluminium foils in batteries. Here we're just going to represent these with some aluminium foil. We've also got some sugar or salt. So this is going to represent some of the proprietary chemicals that are in the electrolyte material. And finally, we have some iron filings, and these are going to represent the mixed metal oxides in the cathode of the battery. So here we've got our mixture that's come from the shredder. We're going to agitate that to mix it together. Now, quite often in the shredding process, a water spray is used, and that's for safety reasons, so it's to stop the products of the battery from reacting in the air when they're shredded, which could lead to a fire or to a thermal event. So when the material comes through the shredder, it's often quite wet, and often aqueous processes are used in the process of recycling. So we're going to add some water here. just going to give that a little swill about. Now, what do we notice? What's happened to the material? Some has floated, some has sunk to the bottom. So how might we be able to recover some of the material that's floated to the top? Okay, so here I've got a little sieve. And one of the processes that's sometimes used in recycling is called froth flotation. And that is simply creating a froth so that some materials float to the surface of a tank. And here we're scooping out the polystyrene balls that are representing all of the plastics used in the lithium-ion battery. And you'll see that some of the balls have become entangled with the electrode foils. So we haven't got perfect separation, we've actually got a bit of a mixture of materials in here. And sometimes in recycling what we need to do is to repeat the process several times in order to refine the purity of the material, because obviously we want the material that comes out of the recycling process to be as pure as possible to make better next generation batteries. So in here we're left with a mixture. We've still got some electrode foils, we've also got the material that's representing the mixed metal oxides, and we've also got the salt dissolved in the water that's representing the electrolyte chemicals. What might we do next to be able to separate these materials? Well, I've got a magnet here. We know that the iron filings that are in here are attracted to the magnet. And in actual fact, when we think about battery cathode materials, there's cobalt and nickel and different materials in the cathode materials that have got magnetic properties. So sometimes this can be used as a basis for separating those materials. Now, I recommend to keep your magnet clean, if you put it in a little plastic bag, it makes it much easier to get off the iron filings at the end. And so if we dip this in here and swirl it around, and you can see that we've managed to remove quite a lot of the cathode material quite cleanly using this magnetic process. If we go around for a second pass, yeah, so we got most of the material the first time, the second time we picked up just that little bit more. And so now we're left with, okay, there's a little bit of plastics in there that we didn't manage to scoop up the first time, but we've got the electrode foils in the bottom, and then we've got the liquid that represents the electrolyte. So I've got the little sieve again, and we could now pour this through, and then what we've done, we've caught those electrode foils in the sieve, and the electrolyte material has passed through the sieve. Now, I've just tipped everything back into the one jug, because that's what I've got here. But if you had several jugs and you completed that material in several different steps, and separated out the plastics, and then the cathode material, and then the electrode foils, and then the electrolyte. If you looked at those different jugs, what might you notice? Well, the material wasn't cleanly separated at each different step. So we did get some examples of contamination. And as I said earlier in the video, often in recycling we have to repeat the process several times to refine the quality of that recycled material. So this is one example of material separation in the context of lithium-ion battery recycling. There are some lithium-ion battery processes, such as pyrometallurgy, where we take the battery material and we can put it into a smelter, regardless of whether it's been shredded or not. But the problem with that process is that some of the material gets consumed by the smelter, and so we don't get an optimum recovery of materials at the end of it. Also, there are some techniques for lithium-ion battery recycling where we might not want to shred all of the materials, because as we've seen, the challenge with shredding is that materials become mixed together, they become contaminated, and you can't always recover materials as cleanly as you would like. Now contrast that to perhaps taking a lithium-ion battery apart carefully by hand or by robot or machine, you'd be able to separate the constituent parts of the lithium-ion battery much more cleanly, and that might then lead to better recycling outcomes. If you've enjoyed this activity and want to dig a little bit deeper, there's some resources on this slide that you might like to follow up. And if you've got any questions, I'll be available to talk to in the Q&A. Thank you very much. I hope you've enjoyed the experiment.